Nice being with you again, my wonderful scholars. JAM past question 2001, question number 14. The driving mirror of a car has a radius of curvature of 1 meter. 1 meter. A vehicle behind the car is 4 meters from the mirror. Find the image distance behind the mirror. Here the question is on optics. The question wants to know your understanding of optics. There are key things to note here. In optics, there's something called mirror equation. Before we go to mirror equation, let's get our parameters out for easy understanding. Solution. We have radius of curvature. Let's say R. Radius of curvature 1 meter. We have a driving mirror. Note it down. There's a reason for that. Driving mirror. Note it down. We'll still come back there. We have a vehicle. Behind the car is 4 meters. A driver is observing a vehicle from the side mirror, the driving mirror of a car. And the object is 4 meters behind. We call it object distance. The distance from the reflector of the mirror to the object is called object distance. From the mirror to the object. From the mirror to the car. Object distance. Symbolized with U. Object distance is U, 4 meters. Then we are being asked to get the image distance. The image will be formed, or the image will appear behind the mirror. So we are looking for image distance. We use V. Question mark. Our image distance is the target, is the unknown. We put question mark. Okay. To solve this question, we'll be applying mirror equation. Mirror equation is an equation in optics that connects your object distance, the image distance, the radius of curvature, and the focal length. The equation that connects your image distance, object distance, radius of curvature, and the focal length of a mirror is what we call mirror equation. So we'll be applying a mirror equation. But there is a challenge with mirror equation. That challenge is what we must resolve now. In mirror equation, there is something called a sign convention. A sign convention. Let me put the mirror equation first. Okay. Mirror equation would say plus or minus 1 over f is equal to 1 over u plus or minus 1 over v. This is the challenge. That's the equation. But there's a challenge with sign convention. When do you use plus and when do you use minus? And that's what we'll rectify at this point. Okay. There are two kinds of images. We have real image and visual image. Real image, just like the name sounds, is the one that can be caught on the screen. It's there. But visual is an illusion. It can be caught on the screen. It appears as if it is there, but it's not there. There is no actual passage of light there. That's why it's visual. But where there is actual passage of light, it's said to be real. That's what we see in real image, also in cameras. But yeah, we're concerned with mirrors. So real image takes the sign convention plus because it's real. There is gathering of light there. Light rays converge there. But visual image is picking the sign convention minus because there is no actual gathering of light or actual passage of light there. Just an illusion. So the question becomes, why did I specify driving mirror? A driving mirror is using a special type of mirror, curved mirror, called convex mirror. Properties of the image include it is diminished, the image is diminished, the image is erect, is standing upright or erect, and the image is visual. So for that reason, we'll be using the negative sign convention there. Minus. Let's go ahead to solve. Okay, I'll be reducing my mirror equation to minus 1 over f equals 1 over u. Please take note, your 1 over u must come before 1 over v. Why? Is the image that is either visual or real. The plus or minus is adding meaning to v and not to u. The object is always real. The object is always real. So the sign convention must come before the image and not the object. Please take note of the proper arrangements. Okay, let's forge ahead. Minus, our image is visual. So minus minus both sides. 1 over V. So we can go ahead and solve. Recall, we're looking for image distance. We're looking for image distance. Okay. Then go back to your parameters. Are you seeing F? Is F anywhere? Okay, there's no F there, but this is why it's good to understand your physics or your optics. There's a connection between F and R. Radius of curvature. If you get a mirror, then the center of the mirror called pole. When you draw a straight line from there, forgive me, when you get your mirror, okay, let's see from the board. Let me position this my convex mirror. This is driving mirror. This is silver surface. You are not seeing from there. This is my reflector. I see from there. That's why it's convex. Then every curved mirror is cut away from a sphere, just like a circle. Let me complete the original object that will cut off the mirror from. A curved mirror was cut off from that sphere in 3 dimensions. Just like it appears like circle in the 2 dimensions. It was cut off from here. Okay, so going back to that actual body, that sphere, we'll be having a middle called center of curvature. The center of that sphere is center of curvature. Then any straight line, okay, before then the center of the mirror itself is pole. The mirror is what? Pole. Then draw a straight line running from the pole through the center of curvature until it cuts the sphere. That straight line is called the principal axis. The principal axis. So the gap from the center of curvature to the center of the mirror called pole is what we call radius of curvature. The gap from the center of curvature to the center of the mirror called pole is what we call radius of curvature. Then half of your radius of curvature is your focal length. Radius of curvature divided by 2 is our focal length. Therefore, this is the focal length. Okay, what am I trying to prove here? I want to prove the fact that R is equal to 2F. In the same way, F is equal to R over 2. This is the connection. So do not panic. Whether you are giving radius of curvature or focal length, you can manipulate and go on with your solving. You can see we've done that. So in this question, we're giving radius of curvature. So to get it back to focal length, what we'll do, we'll slash it by 2 to get focal length. So coming back here, 1 minus 1 over, then our focal length, we'll have R as 1. Half of 1 is half. 1 divided by 2 is half. Then our focal length will be half is 0.5. 0.5. That's my focal length. I can go on with my solving. 1 over, my object distance was given, and the object distance is 4 minus 1 over V. V is what I'm targeting. I want to get V. I'll push on. Okay, let's continue from here. We'll continue from here. I'll have, are you aware that 1 over 0.5 is the same thing as 1 over 2? And the reciprocal of 1 over 2 will be 2 over 1. 1 over 0.5 will be 2 over 1. Are you aware? So you need to know that. So we can push ahead. So 1 over half is the same thing as 2 over 1. The reciprocal. Reciprocal of half is 2 over 1. Then to push ahead, I'll be having 1, forgive me, minus. Instead of 1 over 0.5, I'll put 2 over 1 equal to 1 over 4 minus 1 over V. Are we together? Let's continue. My target is 1 over V. Let me cross it to the other side. It becomes positive. 1 over V is equal to. Remember, I crossed 1 over V, but this one wasn't crossed. It maintains its position, 1 over 4. Then this one will come over there. The minus will change to plus. Plus 2 over 1. We'll continue. 1 over V is equal to the LCM. LCM of 4 and 1 is 4. 4 divided by 4. Will give me what? 1. 1 times 1. 1 plus, bring it down. 4 divided by 1 is 4. 4 times 2. 8. We'll continue. We'll continue. 1 over V is equal to 1 plus 8, 9 over 4. We take reciprocal again. We're looking for V and not 1 over V. The question is targeting V and not 1 over V. You reciprocate. Therefore, 1 over V will now turn it V over 1. The same thing happens in equation. You do the same thing. 4 goes up, 9 comes down. 4 over 9. Therefore, V is equal to 4 over 9 meters. We'll go back to our options. Okay, option B is the correct answer. Please stay tuned and subscribe.